All right, so this will just be a short video. This is really important because we are going to talk about what we just did. All right, so we're going to use the word thermodynamically favored. We've used this before when we know that K is greater than 1, because remember that if we're going from reactants to products, if I just look at an equilibrium and I'm not thinking about enthalpy, entropy, or Gibbs free energy, if I just look at K and I want to go in this direction, if K is greater than 1, then that reaction will be favored, thermodynamically favored from left to right. Now, we're also going to use the word thermodynamically favored for reactions in which delta G is equal to 0. That way, we're not thinking about spontaneous with respect to immediately or without cause. It's important that you know the word spontaneous because you'll hear that especially when you go to college. But just remember that thermodynamically favored could mean it could happen over a second, a minute, or days. Now, exothermic reactions are thermodynamically favored. We said that, right? And reactions high in entropy are thermodynamically favored. Therefore, there's no need to calculate delta G. We know it is thermodynamically favored. If delta H is exothermic and delta S is positive, both, we know it's thermodynamically favored. Now, if this is an endothermic reaction, which is not thermodynamically favored, and S is negative, which is also not thermodynamically favored, if they're both thermodynamically not favored, then the reaction is not thermodynamically favored, and it must favor the reactants. Again, when delta G is greater than 0, the reaction is not thermodynamically favored. When delta G is less than 0, the process is thermodynamically favored. So this can get kind of confusing. Delta G can be negative or positive. Delta H can be negative or positive. And delta S can be negative or positive. Now, when delta G is negative, it's thermodynamically favored. When delta H is negative, it can be. And when delta S is negative, it can be. But I have to look at the magnitude of these to see which one is having influence over the other, right? Because I could have a negative delta H, but a very, very small positive delta S, and it could still be thermodynamically favored. So what we do is we look at the equation and see which one of these is having more weight, or driven by enthalpy or driven by entropy. However, if they're both favored, which means this is negative and this is positive, then we know we don't have to calculate because that's thermodynamically favored. So if this is negative, or if this is negative and this is positive, I know it's thermodynamically favored.